I'm not good at singing, and I'm not good at harmonizing either. So, I want to build a machine that will automatically harmonize with me. It's got to be powered by a microcontroller because I'm not good at microcontrollers. It needs to record my voice and then turn that into a note or frequency. I'd like it to look like a microphone. I mean, the screwdriver looks like a microphone, so that would be fine, but I can't fit the microcontroller in there. I want to be able to adjust the harmony with buttons. I want it to play back a sound at a certain frequency. It's got to play a harmonic sound, so I need to come up with the algorithm to do that. I had bought this back in like 2011 or earlier. Arduino ATmega 2560, so it's slightly more powerful than the Uno. But then I also found on Instructables and GitHub, people had made a guitar tuner that will use the slope of the waveform to figure out what frequency the guitar is in. So I figured if it's good enough for a guitar, it could probably listen to my voice. Another thing is I could use this existing guitar tuner. I've opened it up. It has a microphone that is very similar to this one. It doesn't have that paper mesh on the top of it, and it doesn't have this potentiometer, but the barrel is like the exact same diameter and it's the same color. So I can't help but think they're basically the same thing. Other ideas I have is just play a sound into your ear of what sound you're supposed to be singing, and then it plays the harmonic. So then you have to regulate your voice to the right pitch, and then you're basically just playing a melody on a keyboard, and then it's going to harmonize. So that's kind of like well, I didn't get it to work, but I've got the note playing in my ear, and it's playing a backup vocal. Another thing that I might need to do is to do a low pass filter, and I can do that not in software but in hardware. I found a way to make a hardware low pass filter on a microphone. So I'm gonna start and see what I can do. I'm not very good at this electronic stuff, microelectronics, so we'll try it out. Okay, I've got my code here that I got from online, and I just renamed some variables, but it doesn't really matter. In the loop down here, we're just going to print out what is on analog 0. All right, there's some red lights on there, so that's good. Here's the code that I took parts of. And let's go ahead and upload it. And I get this all the time. Come on, just write it. Okay, let's try it again. Okay, so it was because I had my card reader plugged in. Okay, so now it's on there, and it looks like it's transmitting. I can see the serial line there. Oh, there we go. Look at that. So now we're getting numbers, right? It's always 0 or 1. Scratch the surface of the microphone. No change there, but it is going between 1 and 0. So what I'm going to do is I'm going to change the tool to serial plotter, and then we'll get a better idea because we can see. There we go. So what we want it to do is to jump to higher numbers, like, oh, look at that. Did you see that? Yeah. So now that looks like it's actually listening. Maybe not. Okay. I'm going to yell into it. La. Ooh, look at that. I got a big spike. La, 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 la. Boo, boo. Pa, pa. Yeah, that's not good enough. I have to really yell into it. Nothing's happening. See, nothing's happening. Ah! And then I get a nice little pop. That's it. Bah! 1, 1, 1, 1, 1. Pop! Nothing. Boom! No. There we go. We got 166. Ah, so I blow directly into it, and then I get some. So that's not gonna be good. Blowing into it is not gonna do what I want. So there's a potentiometer on here that's supposed to adjust the gain. Nothing. Give it another quarter turn. La 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 la. Nothing really. I mean, it dropped from 1 to 0. That's not good. La 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 la. Nothing. Okay, let's go back the other way. La 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 la. Not reproducible results. Okay, so this microphone is garbage. When I tap on its surface, no spikes. That should be big jumps. Nothing. Well, I just looked at a pinout diagram. This part here is the ground. The right side is first and the left side is second. And then there's a mic that's right in between here. And so this is obviously not meant, it doesn't have 4, it only has 3. It has ground, right, and left. I'm just gonna test. So this is my mic. This is the end of the mic. You can see there's 4 things on this side of the mic, and there are 3 things on the side that plugs into the headset. So if I connect the ground, which should be the bar bottom pin, to the ground on this other pin here, I should get a beep. I get nothing. Wow. The left channel with the left channel. Okay, left channels are connected. Try the right channel with the right channel. Right channels are connected. And microphone with the ground. Ah. So the bottom here is not ground, but it's microphone. Okay, so now let's check this big adapter. See what it is. So we've got microphone. Oh. Okay, so microphone is ground now. Oh, I gotta think about this. How is this gonna work? So if I plug it in this way, I don't have ground anymore. And I think I need ground. I need ground and microphone. I need 2 separate wires in order for the microphone to work. But if I do it like this, then I'm not gonna have ground. I'm just gonna have microphone. So my best man at my wedding, he gave me this awesome oscilloscope. So let's use the oscilloscope and see if we can see an audio reading off of the mic. Auto trigger. I just want it to detect my voice. Can you please just detect my voice? Will you please just detect my voice? Nothing is changing at all. Would you please just detect? Ooh, so it's getting 400 hertz. Was I singing near an A? I don't know. Hello? Oh, it's not working anymore. Okay, I think I'm gonna have to do a better clip. Okay, maybe. La, la. Now is it just, if I connect these two, that it goes ba, 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 ba. Yeah, I'm not seeing a lot of change going on. Ba. If my oscilloscope can't figure it out, then how is anything else supposed to figure it out? Oh, come on. I don't know, man. Well, the end of my mic has 4 pins. What about the Raspberry Pi? This is a Raspberry Pi 1. This jack here is a headphone jack. It has 5 metal things coming out of there, but it only reads, even though all 5 of those are soldered in, this one right here is ground, left or right. This one over here is left or right. That one is ground, it's not microphone. So even if I desoldered this, I wouldn't be able to get the right thing. But you know what does have this cool 4-pronged jack in it? That's right, a phone does. And I have an old iPhone 5C. I really like this thing. That right there, iPhones used to have that exact connector that I need. So I'm gonna try to pull that out of my old iPhone. Deep within the bowels of an iPhone 5C, there is a headphone jack. And that headphone jack supports these 4 channels. There it is. So I want this headphone jack. But as you can see, my fingers are much, much bigger than those tiny, tiny pads. What can I do? Well, there's this thing, and if you peel it back, there are human-sized pads underneath some what looks like Captain tape. Now we just need to figure out which pins are which. Hold down on the mic. Ah, there it is. So mic is that one up there in the top corner. Okay, that appears to be ground actually. Alright, I have no idea how to solder. That's probably a terrible connection right there. Okay, what do you know? Now I just gotta get this pad connected to a different wire. And we'll use red. We could use yellow, but red is like record, right? I can hear again. Plug that into there, and that should be mic. Woo! Okay, I think I finally plugged it in.